Okay, this is Ms. Whitaker and Ms. Hennebree, and we are going to be going over the review for the Unit 3A mid-unit test coming up. So let's just briefly go through here. I'm just going to, most of you did really well on the review. There were just a few that had some questions on a couple of these, so let's make sure we go over those. And I'll give you brief explanations for each one, just so you know what the thinking is behind each question. So let's start with number 1. It says, which of the following equations represents a line with a positive slope and a y-intercept of 3? So we're looking at a positive slope and a y-intercept of 3. Now let's just keep in mind this whole time that slope-intercept form is y equals mx plus b, where m is the slope and b is the y-intercept. And in this case, we have to have a positive slope, so our m would be positive and our b would be 3. I see a negative slope here, I see a negative slope here, and I do not see a b right here. So it has to be c. This has a y-intercept of 3 and a positive slope, so c has to be your answer for number 1. Okay, for number 2, they're looking for the graph that best represents the equation y equals negative x plus 5. Now this equation is in slope-intercept form already with a negative 1 for the slope and 5 for the y-intercept. So the first thing I'm going to do is look for the y-intercept. This one's not at 5 and this one's not at 5. So A and B are both have a y-intercept of 5. So that's what I'm going to look for first. But then I know that my equation has a negative slope. Letter B has a positive slope. So I know it's got to be letter A because the other ones cannot be, whether it's because their y-intercepts are not 5 or because they have a positive slope. This one has a negative slope. If I did the rise over run, I would be down 1, right 1, down 1, over 1, down 1, over 1. So that is a negative 1 slope. And it is going down from left to right, so I know it's negative. So your answer, number 2, is A. All right, number 3, rewrite the equation 2x minus y equals 4 in slope-intercept form. So right now, I know it's in standard form because all my x's and y's are on one side. And I'm going to rewrite into slope-intercept form. So I'm going to rewrite this right here, and when I want to put it in slope-intercept, I'm really isolating the y. So I want y equals mx plus b format. So the first thing I'm going to do is subtract 2x from both sides, and that leaves me with a negative y equals, and I'm going to go ahead and turn these around to put in mx plus b format. So that's a negative 2x plus 4 because the 2x is negative and the 4 is positive. But then I still have this negative variable, and I don't want that. So I can pretend that there is an invisible 1 there. It's just a given. And I can divide both sides by a negative 1. So make that negative. So those cancel. That leaves me with y equals a negative divided by a negative is positive. So positive 2x. And then a positive divided by a negative is negative. So minus 4. So that's my answer, isolating my y, which puts it in slope-intercept form. Number 4, which equation best represents the graph of a horizontal line? Horizontal is actually that line right there. It goes side to side. Think of horizon as horizontal, looking out at the horizon. So side to side. So I'm going to look to see which one of these makes a horizontal line. I know that this one does not because 6x, 6 would be my slope. So up 6 over 1, up 6 over 1. So that would be a slope to it. X plus 6, that's a slope of 1 with a y-intercept of 6. So I know that is up 1 over 1, up 1 over 1, up 1 over 1. So I know what that line looks like. So it's going to be one of these. And we got to figure out, how do we decide which one is horizontal, which one's vertical? So what I do for letter A, y equals 6, I would make a quick table of values when x is a negative 2, negative 1, 0, 1, 2. Those are the ones I usually use because that keeps you in the center of your graph. Y is always 6. No matter what x is, y is always 6. So if I graphed that, that would look like negative 2, 6, negative 1, 6, 0, 6, 1, 6, 2, 6. It would, when I connected it, it would look like a horizontal line. So that's going to be my answer, I know that. But if I were to do the same thing over here for letter B, x equals 6, make my table of values again, knowing that x is always 6, no matter what I put for my y, and knowing if I graphed that, if x is 6, y is negative 2, 0, and that would make a vertical line. So vertical line for when I have an x equals a number. That means x is always going to be that same number no matter what the y is. Makes a vertical line. It's undefined slope. There is no change in my x's, so y over x would be change in my y's over 0. In this case, it would be plus 2 every time. And then on letter A, I have no change in my y, so the 0 would be on top. So when the 0 is on top, it's a 0 slope. When the 0 is on the bottom, it's an undefined slope. So remember that. Okay, number 5. The graph represents the cost in dollars for printing t-shirts. Which statement can be interpreted from analyzing the graph? So just looking at the graph, I know when there are not any t-shirts, there's a $50 cost involved. So I've got to wonder what that is. That must be some kind of setup fee or just a fee to even place an order. And then I'm going to look at my rise over run. So it looks like for every $10, I go over 2 shirts. So $10, 2 shirts, $10, 2 shirts. So that would be $5 per shirt. So I know that the cost per shirt is $5 and there's a setup fee of $50. Now look at my other answer choices. There's not a cost per shirt of $10. You got to make sure you look at your scale down here is every 2. The cost per shirt is $5. That's true, and there is no setup fee. That's not true. So that's okay. This is not true. That's not true. Letter C, the cost per shirt is not $10, but there is a setup fee. So the only one that works for both is letter D. All right, number 6. Elton's electrical charges charges a service charge of $45 plus an hourly fee of $10 an hour, and I would probably write that thinking $45 plus $10 an hourly fee. What's the y-intercept? Now, if I were to turn this into slope-intercept form, all I would need to do is exchange these places, these positions right here. So y equals $10 an hour plus 45, 10 being my slope for every hour, and then my y-intercept would be 45. So that answers number 6. Number 7, which of the following is not a valid conclusion about the equation y equals 1/3 x minus 5? Okay, so letter A says the line has a positive slope. Now there is, here's my slope, 1/3. So it looks to be positive. So this is a valid, so I'm going to say this is, or this is true. Letter B, the line of the equation will pass through the y-axis at 0, -5. Now I know my y-intercept is at a -5. So I know that that's what this is. So this is also a true statement. Letter C, the line of the equation has an x-intercept of 15, 0. So if I just plugged these numbers in, so 1/3 of 15, plug in 15 for x. 1/3 of 15 is 5. 5 minus 5 is 0, which should be my y value. So that looks true. So that looks to be my x-intercept. So that again is true. So hopefully letter D is not true. The line of the equation will pass through 3, 5. So 1/3 of 3 is 1. If I plug this back into the equation, minus 5 should be a -4, but they're telling me it's 5. So the line will not pass through this point. So this is not a valid conclusion. Number 8, use the following graph to answer the question. So the first thing they're asking is write the equation of the line shown. So I always want to make this in slope-intercept form, y equals mx plus b. So what I need is the slope and the y-intercept. The y-intercept is right here where it crosses the y-axis. So I know that it is plus 3. I know it's y equals something x, so I just need to find the slope for now. I know it is a positive slope, and I'm just going to pick 2 points. I'll just pick this one right here, and then this one right here. So it looks like I'm going up 1 and over 2. So that makes my slope, rise over run, at 1/2. So my equation is y equals 1/2 x plus 3 if I'm following slope-intercept. The x-intercept is where it crosses the x-axis, so that's a -6. The y-intercept, we noted, is at 3. So keep in mind, slope-intercept form, that's going to give you a lot of information there. Okay, a lot of you struggled with number 9. This says the table below shows the profit earned from ticket sales. It doesn't say the cost of tickets. It says the profit earned from ticket sales at a recent football game. What was the price of each ticket? Now, it's not as easy as just taking $500 and divided by 50. That's not going to give us a price of each ticket. It's the $500 that's the profit. So what I need to do is think of these as points on a graph. At 50 tickets, it's $500 profit. At 100 tickets, it is $2,250 in profit. At 150 tickets, it's $4,000. And so think of that as a graph. If I were to graph that, at 50 tickets, it's 500. At 100 tickets, it's $2,250, and on and on. And that would be a graph of my profit. So it's not as easy as just dividing or setting up a proportion. This is actually a slope. If I can find what my slope is, then that's going to tell me a price per ticket for every ticket. If my tickets are down here and my profit is right here, then if I can find the slope, it's going to give me the price per ticket. So to find slope with the table, I look for the change in my y's. This happens to be adding $17.50 each time. And my change in my x's is adding 50 each time. And knowing the formula for slope is the change in my y's over the change in my x's. Looks like I can just make that $17.50 divided by 50. When I simplify, I'll get $35 per ticket. Okay, so remember this is a slope problem. Slope's going to answer the question for me. Now if I look at number 10, write the equation of the line shown below. So the first thing I'm going to look at is my y-intercept at 7. So I know it's going to be plus 7. Y equals something that has to do with x, some kind of slope x plus 7. So I'm going to look at my slope now, rise over run. I do know it's negative because it is going down from left to right. So I'm going to choose 2 points. I'm going to choose my y-intercept, and I'll also choose another point that's on the line. So I know it's going down 1 and over 2, so it is a negative 1/2 x plus 7. Remember that slope-intercept form, y equals mx plus b. All right, number 11, Susan and Marcos have cellular telephones. Susan paid $56 and used her cell phone 200 minutes last month. Marcos used his phone for 300 minutes and he paid $67. Those sound like points on a graph to me. If they're both charged the exact same way, so that's basically if they're both charged the same slope, if I was using an equation, which of the following equations could be used to find the cost of their cell phone bill for X number of minutes? All right, so what I need to do is think of those payments per and the amount of minutes that they talked. Then I can use those as points on a graph and find the change in my y's over the change in my x's. So the key to this one was figuring out what the points were. Knowing what depends on what? Well, the cost depends on the minutes. So the minutes are my independent X values. So I had a point at 256 for what Susan did. And then I had a point for Marcos that was 300 minutes, and that cost 67. Knowing that the Y's depend on the X, the cost depends on the minutes. So then I can use my slope formula of Y2 minus Y1 over X2 minus X1. So 67 minus 56 over 300 minus 200 gives me 11 over 100. It's also 0.11. The only one that had a slope of 0.11 is letter B, and that $34 y-intercept is going to be just the base cost of having that phone. And then they add the additional minutes. So it's 11 cents per minute. What was left over was the $34, which we can assume is that base fee. All right, number 12, we talked about how if you had graphed number 12 and graphed the x and y intercepts that they give you in letters C and D, that might help you understand the problem a little bit. So what I'm going to do is make a little graph over here, and I'm going to graph the x-intercept at 10, 0. And then I'm going to graph the y-intercept at 0, 500. And then connect those points. And notice that it's a negative slope. So when in letter B, when I need to write the equation, I know it needs to be a negative slope. Now I know it's paying off $50 per month. I know that months is my x-axis. And what's on the y-axis? Well, what does this $500 represent up here? That's the balance on the credit card. And I'm slowly paying it off every month. So as the months go by, the balance gets smaller. So this would be the balance of the card over there on the y-axis. So the variables would be the months, and the y is your balance of the card. Hopefully just going ahead and graphing it using the clues that I have helps you understand it. So I know I need slope-intercept form. I know the slope is negative 50x or m, whichever you want to do. And then I know that my y-intercept is at plus 500. So that's your equation. And the meaning of the x-intercept is paid off in 10 months. After 10 months, that there is no balance left. Oops. Paid off in 10 months. And then the y-intercept, the 500 is where the starting balance is. So I'm going to write that right there, starting balance of the card. So hopefully, like I said, do C and D first, use the clues that you have, and just kind of step back and try to understand what the question is saying, and think about what that y-axis would represent. You probably would figure out the x in months, but the y is not exactly the cost, and it is not a positive slope. It is a negative slope because you're paying it off, and so that that y-axis has to represent the balance that's left on the card, and it goes down over time. All right, number 13, which graph represents y equals negative half x minus 4. So let's look at the clues that I'm given. Here's my y-intercept of a negative 4, and my slope is a negative 1/2. So let's look at negative slopes. This is negative, that's positive, this is negative, and this is positive. So now I'm only down to A or E. And then I'm going to look for my y-intercept of a negative 4. This is at a negative 1, so that's not it. Here's my negative 4. That's what I'm looking for. So that's as easy as it can be when you have slope-intercept form. It's just so easy to spot using the y-intercept and that slope. Make sure you look at the clues that you're given. All right, number 14, the amount that a video repairman charges for his services is based on the number of hours that he works. The charges in dollars, C, is given as a function of the number of hours, H, by the equation, C, charge, is equal to $14 an hour plus 25. So which sentence best describes his charges? He charges $25 an hour. No, he charges $14 an hour, so it's not letter A. He charges $14 per hour plus $25 per week. No, that's not it either. Not per week. He charges $14 per hour plus a flat fee of $25. Yeah, that's just for coming out. That's for taking the time out of his day and making the trip, usually to cover gas or whatever. And then he charges you per hour with that $14 fee. That's pretty cheap. And then letter D, he charges $14 for the first hour and $25 for the remaining hour. No, that's just silly. Okay, so number 14 is C. Number 15, what is the slope of the line that passes through the points -2, 7, and -6, -3? This is the straight up slope formula that's in your flip book, y2 minus y1 over x2 minus x1. It's the change in the y's over the change in the x's. Just make sure you're consistent. You may start with either point, but make sure you're consistent with the numerator and the denominator, with your y's and your x's. So I'm always make this first one x1, y1, just to be consistent. Then this is x2, y2. So then I will do y2 minus y1 over x2 minus x1. I'm going to change that to plus plus. So then I end up with a -10 over a -4, which turns out to be 5/2, and that is positive 5 over 2 after I simplify. All right, in number 16, given the graph to the right, answer the following questions. The y-intercept, where it crosses the y-axis, is 4. The slope is rise over run. So I'm going to get a couple of points here. I can take this one right here and my y-intercept. So I'm going down 2 over 1. So that would be 2 over 1. And that's also negatives. It's down 2. So it's a -2 for my slope. The equation of the line, well, right here I'm given everything I need for the equation. Y equals -2x plus 4. I just need the slope and my y-intercept. Does the line pass through 3, 3? Well, 3, 3 is right here, and I'd say no to that. And does it pass through 2, 0? Yes, that is actually my x-intercept. So yes, it does. And remember, all I needed to do to check if any point goes through it is to plug it back into my equation, plug in your x into the x and solve that, and it should result with your y value. And that would be a point that's on that line. A point on the line has to satisfy the equation of that line by plugging in x's to get your y's. All right, number 17, Marcus delivers pizzas 3 nights a week. He receives $15 per night plus $10 for every 20 miles he drives to make the deliveries. All right, so it looks like miles are on the bottom, number of miles on the bottom, and earnings in dollars on the left. So he gets a flat rate of $15 for every night. So we're going to start at 15. So it can't be A and it can't be B. So if he doesn't drive anything, he at least gets $15. And then $10 for every 20 miles. And let's see. It looks like I have this hidden on here, but your answer is going to be D, because for every 20 miles it's going up $10, and it looks like it's only going up $5 on letter C. So that's only a $5 for 20 miles. And this represents $10 for 20 miles. So D is your answer. Okay, so let's make sure we understand when we have an equation that's just y equals a number or x equals a number, like we see in 18 and 19. Let's just graph y equals 3 first. And for these, I told you to go ahead and make a table of x and y values. And this is just saying that y is always 3 no matter what my x is. I can graph that, -2, 3. Let's see. 1, 2, -2, 3, -1, 3, 0, 3, 1, 3. If I graph that, that's a horizontal line. I know that the y-intercept is at 3, very much similar to what you see in the equation. And the slope is 0 because the changes in my y's is 0 over 1. So with 0 as my numerator, my slope is 0. Just graph it, and you'll be able to see that. All right, same with number 19. Let's make a table of values. X's and Y's. Our X is always going to be a -3, no matter what my Y is. So X is always a -3. That makes a vertical line, which I know is undefined slope. And there is no y-intercept, not even 0. Because if 0 was the y-intercept, it would at least be over here, but it's not going to touch the y-axis ever. So when there is, this is a change of 1 on top and 0 on the bottom. So when 0 is in the denominator, it's undefined slope. All right, number 20. It's just asking for the meaning of the slope and the y-intercept in this situation. Alyssa's carpet cleaning service charges an initial fee of $60. That's the y-intercept, that initial fee. Just for coming out is my y-intercept. The slope would be the $15 for every 100 square feet, or it just tells you the price per square foot. So we're just talking about, this is a real world scenario, and if you were making an equation of this scenario, what would the slope represent and what would the y-intercept represent? All right, number 21, the graph represents Jacob's amount of fuel in his tank as he travels. How would the graph change if his fuel tank started with 15 gallons? Right now it's at 25, but if it started here, it would be parallel. So it would just shift down 10 units. That's all it would do. Number 22, a car rental company charges 10 cents per mile plus $30 per day for a mid-size sedan. If the rental company changes their mile charge to 40 cents, how would that change the slope on the graph? So right now, the slope is 10 cents per mile plus $30 a day, but if they change that to 0.40 cents per mile plus the $30 a day, that would make it steeper because that amount going up, the cost would go up more for every mile going over, so it would get steeper. On number 23, the line of the equation y equals -2x minus 4 is shifted up 7 units. So what equation would result from this translation? So this is obviously what I see here is the graph for the original equation, but if I'm going to go up 7 units, I'm just going to use my y-intercept as my home base. Go up 7, 1, 2, 3, 4, 5, 6, 7, and it would be a parallel line. So the slope stays the same, but my y-intercept now is at 3. So all I'm doing really is dealing with the y-intercept. That's all that's changing in my equation. All right, number 24, what's the new equation of the line shown if it's translated down 5 units? So we're just going down 1, 2, 3, 4, 5. It's going to be parallel. So it's going to, I need to figure out what the slope is, first of all. So if I figure out, pick 2 points, I'm going down 1 over 2. This is a positive slope. So the original is 1/2 x starting started at plus 3. I'm going to go down 5 units, so I end up at y equals half x minus 2. That's my y-intercept. So y equals half x minus 2. All right, number 25. Troy graphed the line of the equation y equals 5x plus 2. Sarah graphed the line of the equation y equals 5x minus 2 on the same coordinate plane. Which of the following statements best describes the line that Sarah graphed? So Sarah is at minus 2, and the only thing, if you look at the equation, the only thing that's different is the y-intercepts. And so it looks like Sarah's is going to be 4 units below Troy's, but it's going to be parallel. So the answer is C, because the slope is the same. So I know if the slope is the same that it's going to be parallel lines, but she's at minus 2 on the graph, he's at plus 2 on the y-axis, so they're just 4 units apart. Troy is up at plus 2, Sarah's at the minus 2, so Sarah's is 4 units below Troy's. Number 26, the graph of the line L is shown. Then we need to write the equation of the line that's parallel to L and translate it down 3 units. So remember, parallel means the slope's going to be the same. So let's find out what the equation is of our current line. I know that it's minus 1 because the y-intercept is at minus 1. So I'm going to write the original equation here. So it's minus 1. Y equals something that has to do with x minus 1. So I'm going to just choose some points. I'm going to choose this one and this one. I'm going up 2 over 1. That is a positive slope. So 2x minus 1 is the original. And I'm going to translate down or shift down 3 units. 1, 2, 3. So it's going to be parallel somewhat, I promise. So the slope is the same. So it should be at minus 4 on the y-axis. So this is the answer to the question for 26. All right, number 27. The graph is shown in this coordinate plane. I know that the equation is y equals, this is a negative, so I'm going down 1 over 2. Negative 1 half x is at plus 7. And they're saying in the equation, in this question down at the bottom here, in the equation, multiply the slope by a negative 1 and subtract 3 from the y-intercept. So negative 1 half times a negative 1 is a positive 1 half. So y equals positive 1 half x. And then the y-intercept is going to be subtracted by 3. So that's going to be at plus 4. So this is what you should get for number 27. And likewise in number 28, we have an equation of y equals negative 4x plus 5. It says we're going to multiply the slope by 8, so negative 4x times 8. And then we're going to decrease by 6 on the y-intercept. So this is going to be a negative 32x. And this 5 minus 6 is going to be minus 1. So that's your answer for 28. And the last one, number 29. During the marathon, Arizona started running at 8 miles per hour after she had run for 5 miles. How would the slope of the line change if the 8 were changed to 6? So 8 miles per hour is going to be the slope, but if we were to change that to 6, it's going to be less steep. If my slope is lower, it's going to be a flatter or less steep slope than if it were higher. That's it.